and welcome to Learn ADS in 5 minutes. This is tutorial 41 on multi-layer layout basics in ADS. In this tutorial, we will cover the basics of doing multi-layer RF layout design. We're starting with something very simple to create a multi-layer technology file in ADS, understand layer mapping and binding, and then I will give you an example of how to do multi-layer trace routing, and with the automatic via insertion, how easy our job becomes. And then we will turn our attention to manage to see how can we manage different type of via pad stacks in ADS, talk about constraint manager, setting up the clearance rule for various layers, and then work with the planes on various layers. So all these topics will be a very foundation before you embark on doing any multi-layer technology design, may it be for RF board, laminate, module, packages, or LTCC. So a lot of interesting topics in this tutorial video. Now, why we are talking about these topics? Well, if you see the technology is all becoming inherently multi-layer, and the level of integration we are seeing these days is just mind-boggling, and it's only going to go more complex. So, multi-layer technology is the need of the hour, and it is also the key foundation to do multi-technology design, where you have concepts like RF modules, multi-chip modules, and so on, where chips designed in different processes are assembled within a kind of module or a multi-chip module form factor. And all these integration technologies, requires the basic fundamental knowledge of doing multi-layer, layout designs. And I hope with this tutorial, you will have a pretty solid foundation on which you will build upon, would be able to do more complex design as you see in this picture here. And also in future tutorials, we are going to talk about the simulation aspects of these complex assemblies. But again, that knowledge will be incomplete if you don't have the fundamental of doing multi-layer, layout designs in ADS. So stay tuned till the end of this video and hope you will have enough learning to proceed for these kind of designs. Now, before we start, subscribe to my channel. Once you subscribe, click on the bell icon to enable all the notifications. After you watch the video, don't forget to hit the like button and share it with your friends and colleagues who may be interested in watching similar tutorial. All right, let's get started and cover each topic one by one and enhance our learning even further. Now to start with, I will go ahead and create a ADS workspace. And while creating the workspace, let's call it multi-layer basics. And now under show advanced, I'm going to set up a layout technology immediately after creating the library. So we go ahead and create. Now, if you're working on a traditional microstrip, or a normal RF layout applications, you could use one of these, default, technologies. However, here I will teach you how to create your own custom multi-layer PCB technology, which you could use for your design purpose. To do so, let's select Create PCB technology. And now in the dialog box here, you can select the units which you want to work with, the resolution which you would like to work with. So I will let this to be default, and then number of metal layers. So here for this demo, I will use 6 metal layers. However, there is no limitation in ADS on number of layers. You can have 20, 40, 50 layer based designs in ADS, and rest of the options you can select from here. So I'm keeping some of those as defaults. Let's click on next. Now, in this dialog box here, you can assign the material which you want to use for your stack up. Remember, anything which you're doing here can be changed later. But in case you don't want to leave it for later and you want to do it now, you can pick the material of your choice. If your material is not listed here, you can always click on this icon here. And from the ADS material list here, you could add in your own material, either from the database, or you can just simply add a dielectric and define its dielectric constant and loss tangent. Right, so in my case, I will go ahead and just pick the typical, or the default materials here. And again, you can set the thickness. You can define the conductor, inner material as well as the outer material. Outer simply means the top and the bottom conductors, and rest of the conductors are called inner metals. Right, we click on next, and now because we are dealing with multi-layer technology, of course, we need to have a via, and I can give my default template some name. In my case, I have given it a name called default underscore via. Define the pad diameter and the drill diameter as you require. And this by default will be a through via. If you need EM style stackable drills, you can always enable this option so that at all individual layers, you will have a separate via mapping. But in my case, I will leave it unchecked and I will just have a through via model template created here. So we click on finish, and now once we are done, we have our technology substrate for our multi-layer setup which we did. Double clicking on this technology substrate will open up the substrate editor here. And now you can notice the top layer name is con, the bottom layer name is con2, and it is just like some tools prefer to call it top and bottom. ADS uses con and con2. And then you have all the inner layers M2, M3, M4, M5. Now anything which you don't like in the setup, for example, if you want to make all the thickness for all the dielectric layers is 5 mil or 10 mil, whatever you prefer, you can go ahead and modify the same, and this will be updated. If you didn't add your own material at the time of workspace creation, you can do so now. For example, if you click on the dielectric using the material here, I can click on this icon and again open the material definition list and add the material. And once I add the material, I could simply assign the material because it will be available in the list here. Now, if you're dealing with large number of layers, let's say 20, 14, and so on, you could also enable the table-based editing. So here, if I click on this icon, you have the table-based entry, and this is basically for VIA. Now, using these kind of text-based editor, you can go ahead and modify all the properties of your stackup. So again, choice is yours whether you want to do using graphical methods or using the table methods here. And these are toggle buttons. If I click them again, it goes away. Now, once we have our technology substrate, remember the default name of this substrate would be tech. So tech.subst file will get created inside your workspace. Now, if you want to do your own custom layer mapping, you can feel free to do so. For example, if you want to add a new layer on this interface of the dielectric, you could simply right click and you can map a conductor layer, and based on the new layer which you have mapped, you can define the right layout layer to be assigned here, so that when you do your layout design in the substrate cross section, that particular shape or objects get placed on the specific layer as you need. If you don't need this mapping here, or if you want to remove it, just simply right click and select unmap. So it's very, very simple to follow. Now in this stack up, you also see we have a through via with the name con underscore con2, representing I am connecting from the top layer to the bottom layer. And then we have some intermediate via mapping here, right? If you need to map your own via layer for a certain layer, for example, let's say I want to have my via going from M2 to M3. So currently, if you don't have any via mapping, whenever in your layout design you plan to insert a via, it will get inserted with this through via template, right? So in some cases, it may not be desirable, because when you are making this connection only, then you will have this via stub on the top and that via stub at the bottom side, and this will produce capacitive and inductive effect on the higher frequencies. All right, so if you need to do your own custom via mapping, just simply right click, say map conductor via, and once you map, it will come with some default layer name. If you're not happy with that, you can either pick any other layer which you have available, or you can define your own via layer name. For example, here, if I click on add new layer, I can call this layer as via M2, M3, or whatever you wish to call it. So let's call it M2 underscore M3. And the process rule I'm going to select is conductor via. And you can see the layer binding is empty right now. So let me explain what does this layer binding mean a little later. Let's map this conductor layer here. So once we click OK, now you can see the via got mapped, and the layer I'm going to use in my layout is M2 underscore M3 to draw that via. So once I have my own addition and subtraction, and again, this is about layer mapping. So as per the agenda here, we just finished creating multi-layer technology. We just talked about layer mapping. That's how you map different layers at different interfaces. Now let's talk about multi-layer binding. So binding is one of the process in ADS by which you tell which via layers are basically connecting which metal layers. And the same thing could have been done when we added this layer. But let's say in case you forgot to do it, not a problem. We can go to technology, layer definitions, and in this dialog box here, under the layers tab, you can notice there's a binding column. And by default, when you created this technology, all the via layers which you have here are telling which metal layers are getting binded by it. Now here the order does not matter, just that all the layers should be available. For example, if you look at through layer, it is connecting all the layers, but you don't need to follow a specific order like top to bottom or bottom to top. It can be anything. The conductor we created, which was M2 underscore M3, has no layer binding because we added it later when we are done with the technology creation. So here now I know M2 underscore M3 is connecting M2 and M3 metal. I could either manually type it M2 space M3, and this way ADS technology knows that this via layer is going to bound these two metal. Or I can choose not to do that manually because I might be working with 20 plus layer stack up, and I have done a lot of these modifications after I create the library. In that case, you could simply click on this button here called update layer binding. It will go and read the information from this technology substrate. Once we click OK, now you can notice it already knows which layer are you connecting to. So this way, all the layer binding would be updated automatically for you. All right, so these are very fundamental things which we need to take care while creating any new technology. So we are done with the three topics. Now let's focus on doing a multi-layer trace routing. So once I have the right layer binding defined, I have the right technology defined. Let's open a ADS layout. And in this layout, you can notice we have the layers window activated. If you are not able to see this layer window, you can right click anywhere in the free space here, select layers window. And now you're able to see all the layers. However, you notice these layer names are little scattered. They are not following the order which you have in your stack up definition. And if for some reason you want to reorder them, based on your preference, you can do so very easily. So we can go to options, technology, again going to layer definition. And here we have a tab called display order. Now, here is the order in which your layers are currently appearing in the layout, and we can chop and change the way we want. For example, we want these 5 things or these 6 things to be appearing at the top, and I can drag and drop them to the top. And now once I hit apply, you can see this list here gets updated according to our need. Same way, if you need, you can even line up all the via layers in the sequence as they appear, but I'm not doing so at this moment. Now, whenever you add any new layer in your technology, using layer display properties, you can define the color of the layer. You can define the pattern in which the fill will be done on the layout. And also you can define the transparency, how transparent it is, so that when you're doing multi-layer layout, once you draw any object, you can still see below the object in different layers. Also, the shape display by default will be switched on as both. However, you can decide to keep objects drawn on that layer as outlined object, or you can choose it as a filled object. So it's all user controllable, parameters, because you created this technology, so you have all the ownership of this particular technology. All right. So once things are in place to insert trace or to route in a multi-layer, kind of boards, you could use this trace icon inside ADS layout. So you can either click on this option here, or you can go to insert trace or simply press T shortcut on your keyboard. So no matter which option you pick, you can decide on which layer you want to draw the trace, and you can decide the width of the trace. For example, I would start with 5 mm width, and end style I would like to have truncate, and the corner would be the curve, and I would like to keep as a 5 mm, which is equal to my trace width as the curve radius. Now once we start drawing that trace by clicking, and now you can move your mouse, you can see you have a free flowing trace. You can go to any angle. In a particular design process, let's say if you are constrained that you could only draw in a 45-degree or 90-degree, you can always enable these preferences toolbar, and you can do so by right clicking and selecting editing preferences. So if I disable it, you can see that toolbar is gone, and that's how your default look will be. But if I enable editing preferences, so here's a 45-degree lock. That means now you can see whenever I move, above this axis, my trace will only change in 45 degrees. Or I can lock as a 90-degree constraints, and now you can see I'm only able to move in a 90-degree, kind of constraint mode. If you uncheck both of them, now you are back to free flowing, trace entry. So again, depends on your preference what you want to do. So now while doing multi-layer trace routing, if I click on this point and let's say now I want to move to some other layer. So I'm already on the top layer, which is conned. If I want to go to, M2 layer, M3 layer, or any of the lower layers, once I click, I can click on the period key. Now period key will take you one level down in the hierarchy. And now you can notice you are on M2 layer, and that's why the color trace is changing. Now, if I decide to route on this layer, I can continue. Otherwise, if I'm not happy, I want to go down even further, keep pressing the period key or the full stop key. And now you can notice one by one, the layer is changing. And finally, you are back to con 2, which is the bottommost layer. And now if I draw this object here and click again, now to move up, I can use the comma key, which is just one key before your period key on your keyboard. And now when I press the comma key, you can see I moved back up to M5. To get a better view, if you click 3, on your keyboard, you can, rotate the ADS layout into a 3D mode. And now you can see how you're transitioning. So if I press comma key again, now you can see you're back to the third layer. And then once I press one more, you're on M3 layer, then you are on M2 layer, then you are back on the top layer. And once you want to finish, you can click and press a space bar or do a double click, and now you are done with a trace entry. And just now we did this multi-layer trace, and the VR got inserted automatically. Now the question is, how did this VR got inserted? Remember, during our technology creation, we created a default VIA template, and that's what it is using here to draw the VIA objects. All right, now let's start one more routing and see. So we are in a 3D mode. So let's start a trace routing again on the con layer. And from here, I want to go down and I press a comma key. Now you are in second layer. From here, I click and want to go down one level down. And from here, I want to go one level down. So this way you can have this kind of staircase. But notice what happens here. Once I went from fourth layer to fifth layer, let me finish this and explain. Let's click and press the space bar. Now, when I was going from layer 1 to 2, I had a blind kind of view. From layer 2 to 3, I have a blind via. From 3 to 4, I have a blind via. But from 4 to 5, I have this, through via got inserted. Why so? Well, that's because of your stack up. If you look in your technology, there is no blind via or a stacked via definition defined for this layer. And when you wanted to go from this to this layer, it had no other option but to pick up the through layer. So it's all about how you set up your technology, right? So easy to do multi-layer, layout, interconnect design in ADS. All right, so with this, we finish that topic as well. And now I hope you would be able to play with some of these on your own pace. Now, before we proceed further, now whatever we used till now was only having one type of VIA pad stack. And that pad stack got created during our technology creation or the workspace creation. Now, for different layout layers, you may have different constraints, different type of pad stack. For signal routing, you may have a different via pad stack. For ground planes, you may have a different via pad stack and so on and so forth. So how can we manage all that in ADS? To do so, you can go to Options Technology. And remember, all these things are pertaining to technology. And that's why we are always going into Options Technology. Now here in one of the options, you see we have a pad stack definition. And if we enable the pad stack definition, you can see I have one via definition. And that is created in this library. Default pad size is 15 mil and the drill size is 10 mil. Now, if I want to add my own pad stack, I can click on add. Now here I can define the pad characteristics, and on the right hand side, I can define the drill characteristics. So you can choose the pad shape to be circle, square, rectangle, oblong, or whatever you want, like octagon and so on and so forth. So you can come up with your own pad stack, define the width of the pad. You can define the thermal connectivity of the pad, clearance, whether you want to have certain fixed clearance or you want to use a custom clearance rule where you may have some kind of X offset, Y offset, and other shape based clearances. Okay, so all those advanced options are all provided here. And again, in anti-pad, you can either use the clearance rule or you can define your own anti-pad clearance for the via pad stack. All right, so this is how you set a pad. Now on the drill, you can have a circular drill, have a square drill, and so on and so forth. And again, specify the option. So I'm going to go ahead and use, just to show the variation, I'm going to do something very big, say 30 mil pad, and I'm going to use, let's say, okay, let's pick octagon only. So in a circular pad, but I'm going to use drill size of 10 just to create some separation with the existing pad stack we have. Now here we can define as octa underscore via. So that's going to be our pad stack name. And once we do that, we have another pad stack. And this way you can keep adding as many pad stacks as you want. Now, once you have the pad stack, right, we need to create a few rules, and that rules are managed inside Constraint Manager. What type of VI it will be, from which layer to which layer, so we can put all those constraints in the Constraints Manager. So when we go to Options Technology, we do have Constraints Manager. In Constraints Manager, you could define the clearance rules or you can define the VIA rules. Now under VIA rule, if I add a new VIA rule, I can define which pad stack I would like to use. Is it going to be default VIA or Octa VIA? Now for default VIA, I already have the pad stack defined, so I don't need to do anything special. But let's start with Octa VIA. Now, if you want this Octa VIA to be, or template to be used for all the VIAs we have, then you don't need to do anything. Just click apply. And this Octavia, for example, let me call it Octavia. So with this Octavia, you will have it for all the layout layers. But if you only want to use this specific type of via between certain layers, I can define the layer constraint. So let's say I would like to only use this spatial type of via when I am transitioning from cond to M2. And if I want to make it stackable, I can make it stackable. All right. Once I click apply, now this oct via will be used only when I am going to use this guy. Now I can add another via rule, and this, let's call it general. Now in general via, I'm going to use the default via template, and I'm not going to put any layer constraints. That means whenever I need to draw the via except between cond and M2, ADS will use this general. And you can add as many rules as you want again, very easily with this setup here. So while we are in Constraints Manager, we just covered Constraint Manager. Let me also talk about clearance rules, because whenever you are doing your routing, your plane insertion, you will always have certain clearance rule coming out of your DRC, because your process will determine what should be minimum trace to trace spacing, trace to VI spacing, VI to VI spacing, and so on. So all those rules we can define under clearance manager. And here, when I set up a new clearance rule, I can define with an object specific rule, or I can define a general rule. For example, here any to any. And then I can also, in terms of layer, I can use a global rule, which is going to affect all the layers in your stack up. Or you can do a selected layout rules. For example, I would like to pick a layer which is cond, and on cond layer I would like to have this rule. So I can default clearance is 10. That means 10 is going to be used between trace to trace, pad to trace, pad to pad, via to trace, via to pad. So this is just like a matrix. So you can define your own global criteria. But let's say for top, I would like to apply globally a 5 mil. When I apply, you can see all of that got updated. And this one, let me call it cond underscore rule. So that's the one setup I have defined. Now for another clearance, let me prepare another clearance rule. And in here, I will select the layers, and except cond, I am going to pick all the other layers, for example. Now in all other layers, I would like to use, let's say 20 mil and apply. So only cond will follow 5 mil and rest of the layers will follow 20 mil, and it's applicable to all layers. So I'll say all underscore layers, some name, not necessarily to give name. I could have picked up the default name. Now, once this is done, we click OK and we finish that topic. Let's see how it impacts our layout design. Now, let me clean that up. And now under cond layer, let me click on cond so that this entry layer becomes cond here. And let's try inserting a via, let's say with 5 mil. And now once I'm here, I click. And now if I want to move to second layer, I press period key. And notice here now you have the different via template. It's not a circular, remember, because that's the constraint I set. Now, if I want to go to the third layer, now that template is not applicable. The pad stack was supposed to be used when you go from first layer to second layer. As soon as I want to go to third layer, now I'm back to the original, pad stack. And let's go back to the top, and then we click here. And now from second layer, if I want to go to third layer, of course, by default, a circular template will be called, and so on and so forth. So this way, let me just go right to the bottom, and let's say it's the bottom layer, so cond2, and let me just do some routing on cond2 layer here, some at random routing here. Okay. All right. So once I have this trace routed, if I need to modify this trace, I can also do a single click. I can use these handles and I can push the different handles at different location the way I want. All right. And also if you need to edit some trace property, you could double click on the trace, and by double clicking, you could invoke the property dialog box, and here you can handle different widths. For example, on M2 layer, I didn't want it to have 5 mil. I wanted to have 15 mil. And you click apply, and now only for that layer, the trace will change and so on. So all these modifications are done. Now, so once we have these pad stack, we saw, how different, pad stack worked and how our routing got changed. Let's look at planes. How do we insert plane here? So if I go to insert plane, I can use, you can see it's by default using the clearance rule, and the clearance rules, has some number. So if I uncheck it, I could set up my own clearance number here. But once I already have the rule defined, so obviously I would go ahead and use the clearance rule. You can choose what layer you want to draw that object. So let's just start with the bottom layer. Let's say contour layer. And if I draw a rectangle on that contour layer, remember what was the constraint? My constraint was 20 mil. So now this separation between contour trace, also the via, I have 20 mil separation. Now if I want to do the same thing on the top layer, so let's invoke cont layer and I repeat the same rectangle here. Remember what was the clearance rule? It was 5 mil. And now you can notice the separation is only 5 mil there. So again, it's working very, very nicely with whatever you're doing. Now, if I decide to draw the plane on, let's say, M3 layer, and M3 layer was also using the 20 mil clearance. And if I draw a plane on M3, and now again you can see I'm following the 20 mil kind of clearance. And again, you can enable the smoothing options. You can enable the feature, things like that. So once you click some of those items will get smoothened out. Now, once you have drawn the plane and let's say you double click, you can again access that property, modify whatever you need here. For example, if I'm looking at the con plane and I don't want to follow the 5 mil, let's say I want to have a 10 mil clearance, I can apply. And now the plane on con layer will have a 10 mil clearance. So it will live update. Now also sometime when after I have drawn the plane, I need to add a routing, right? So in that case, let's say if I have to draw a trace again, and remember this is the ground plane and I cannot draw the trace, but let me show you what happens. So once I draw here and I go to second layer and I go here, I come back on the top layer and I finish my routing, finish the spacebar. You can notice ADS is complaining because it is saying you are interfering with the other net and that net is the ground net. So if you have this situation after you have drawn it, just right click and you say regenerate the plane. And now it will just update, create a new set of clearance. And now if we look in 3D, that's how our multi-layer stack up or multi-layer design looks like. Isn't that so easy to do in ADS? So no matter how many layers you have, what kind of objects you are drawing, whatever things you are working, we can handle that very, very easily in ADS. So that's all for this tutorial video. I hope you got all the fundamental information and you'll be very eager to start playing with some of these options if you have an ADS license. And again, if you don't have ADS license, go to keysight.com, look for the ADS web page and apply for your evaluation license. You can easily obtain 30 days eval license and try some of these tutorials on your side. All right, so thanks a lot for your time and attention. Look forward to see you in the next tutorial video. Have a great day ahead and have a happy time designing your multi-layer circuits.